Hello, in this video, I will discuss the expenditure function in case of linear preferences. Before deriving the expenditure function, let us review the utility maximization program and the corresponding indirect utility function of these preferences. As we discussed in our video, the consumer's optimization in this case will be a corner solutions if P1 is not equal to P2. So if the prices are not equal, the consumer's equilibrium or the consumer's optimization will always lie at a corner point, and we solve this simply by equating the marginal rate of substitution and the price ratio, and we determine which commodity the consumer wants to consume. So the Marshallian demand function or the Walrasian demand function can simply be expressed as the demand for x1 is if P1 is smaller than P2, he will purchase all x1. So the demand for x1 will be W over P1. If the prices are equal, he can purchase any quantity of x1 from 0 to W over P1, and if P1 is greater than P2, the demand for x1 will be 0. Similarly, for x2 commodity, if P1 is smaller than P2, the demand for x2 will be 0. If the prices are equal, he can purchase any quantity from 0 unit to W over P2 units. And if P1 is greater than P2, he will spend all his budget on the second commodity, and the demand for second commodity will be W over P2. So from this we can derive the indirect utility function as we have done before in video. The indirect utility function BPM is simply the maximum of the two cases. The consumer will choose the one which gives us the maximum of the two. So max W over P1, W over P2. So this is W max 1 over P1 and 1 over P2. So we will utilize this indirect utility function to derive the expenditure function in a minute. Before that, let us derive the expenditure function from the dual problem or the expenditure minimization program. So here the problem is minimize the expenditure P1x1 plus P2x2 by choosing the value of x1 and x2 such that the consumer achieves the targeted utility level U bar. So here also it cannot be solved from Lagrangian optimization principle or by using the tangency rule. So here we consider two cases here. If P1 is less than P2, the consumer will buy the first commodity only, and the value of x2 will be 0. So the demand for x1 will be U bar. So we substitute x2 equals to 0 in this equation, in this constraint, and we get the compensated demand for x1 to be U bar, which is given here. And if P1 is greater than P2, he will purchase no x1, so the demand for x1 will be 0. So for demand for x2, or the Hickeyan demand for x2 is simply given by whether the price is P1 is smaller than P2 or greater than P2. If P1 is smaller than P2, in this case you will purchase x1 only and no x2, so the demand for x2 will be 0. But if P1 is greater than P2, the consumer spends all his income on the second commodity, and we put x1 equals to 0 here, and x2 will be U bar. So the demand for x2 will be U bar. So the Hickeyan demand function for x1 and x2 are these two, and we can express the expenditure function also in two cases. The first case is P1 is less than P2. In this case, the consumer buys u bar amount of x1 and the total expenditure is p1 u bar, and if p1 is greater than p2, the consumer doesn't buy any x1 but buys u bar units of x2, and the total expenditure will be p2 times u bar. Now we can write by combining this two a single expenditure function as epu bar equals to minimum p1 u bar p2 u bar. So we can take u bar out of this minimum operator, so this is u bar minimum p1 p2. So this says is that if p1 is smaller, the expenditure is p1 u bar, and if p2 is smaller, the expenditure is p2 u bar. So this is the expenditure function in case of perfect substitutes or the preferences are linear in this form, x1 plus x2. So this expenditure function can also be derived from the indirect utility function that we derived here. So the indirect utility function, in indirect utility function we substitute epu bar in the place of w, and we equate this to u bar. So we simply substitute w by epu bar max 1 over p1 1 over p2 and equate this to u bar, and this becomes simply epu bar is u bar times, so when this goes to this side it becomes minimum p1 p2. It is because choosing a maximum value here is equivalent to choosing a minimum value. To see this, we can consider simply that suppose that if p1 equals to 2 and p2 equals to 4, so now here it becomes 1 over 2 and 1 over 4. Between these two, the higher value is 1 over 2, so this 1 over 2 is chosen, and this 2 goes and this 2 goes here, so this is 2, so this is 2 and this p2 is 4. So choosing a smaller value here is choosing a smaller value here in the denominator is equivalent to choosing a smaller value here in the numerator. In other words, choosing a maximum value here is equivalent to choosing a minimum value here in this side. So this can be expressed as simply epu bar equals to u bar minimum of p1 and p2. So this is the expenditure function in case of our simple linear preferences x1 plus x2. Thank you for watching this video, and please subscribe to my channel for watching more videos in the future.